And the main topic. This is the I guess this is the topic where it kind of infiltrates all the other topics. Yeah. Today we are going to do something from first principles. Does anyone know what first principles is? So a lot of the maths in methods is applied, but we're going to generate this whole topic just from the very beginning. So in here we have something called a derivative function. And does anyone know what another word of derivative that we can substitute? When something is derivative, what does that mean? Well, in regards to maths, when you hear the word derivative, straight away it should be gradient. They're exactly the same thing. So what we're going to do here, we're focusing on point P. And if I have point P, find the gradient of the chord PQ down, drawn to the curve fx equals x squared plus 3. I've got 2 points that I'm going to relate together. We want to find the gradient from P to Q. So we just really want to whack our ruler there and do a rise and a run. That's all we're doing at the moment. But if we kind of say that this is x equals 1, what goes in here? 4. The answer is 4. And we'll get there eventually. But another way we can say that is the function when x equals 1. It will eventually be 4 in our working out. Now over here, Q. The thing about Q is simply another point down the track. And the way we can write this is we know that it's 1. It's at least 1. But it's going to be a little bit more that we don't know. The letter that we use for a little bit more is H. I don't know why they use H. They just use H. 1 plus something. So we're going across 1, but it's that something is in the space between. Therefore, how can I rewrite the y value here if I don't know it?
4 plus h.
4 plus h, yes, good. Let's take a step back, Tim. As if, let's not relate it to this one. 1 plus h, okay? Of what? 1 plus h, if the x is a 1 plus h. If we're trying to find out what the function is at 1 plus h. Anyone's lost? It's okay if you're lost. A little bit lost. Someone's a little bit lost. Who's a little bit more lost? Or a bit less lost? Okay, let's try not get lost. I'm gonna remember it's rise and run. I have 2 points here. y2 minus y1, x2 minus x1. So therefore, I will write this out just to trigger people's memories. What's my y2? Manny, what's my y2?
F1 plus h.
Good. F1 plus h. And I'm going to take away my y1 z. What's my y1?
Just f1.
Correct. Harry, what am I going to write next? A 1 plus h. Jesse, what am I going to write next?
Minus 1.
Thank you. F of 1 plus h. Okay, still keep going. Now, what does this really mean? A 1 plus h on f. What can we do with that? If this is the x, how else can we rewrite f1 plus h using the information in here? What can we do? Did you say sub? Say
Yeah.
you are correct. 1 plus h. We sub it in. 1 plus h. Yeah, that's exactly what you said.
Completely.
1 plus h squared. Have we fully used the equation though? No. What's missing, Jesse? A plus there. Okay. Let's grab Tim's information from before he said 4. 1 squared is 1 plus 3 is 4. Zach, what's on the bottom?
Like just sub in 1 plus h. Like
What's the denominator equal to?
h.
Good. Okay. 1 plus h squared. How can I rewrite 1 plus h squared, Nathan?
1 plus square. 1 plus h times 1 plus h is that 4?
Yes, correct. What's 1 plus h times 1? Let's do that.
Well, 1 is squared plus 2h plus.
Okay. Yeah, you're right.
Is that?
1 times 1 is 1. 1h plus 1h is
2h.
2 h's. And the third term is
H squared.
h squared. You're on a roll, save. Okay. To finish it off, 3 take away 4. So minus 1 over what Zach said is a h. Still more to go. Now, the top, Emily, what can I...
You can do the 1 minus 1 cancel out, so you just get h squared plus 2h.
h squared plus 2h in any order. Maya, what do you think we can also do now? There's h is on the top and h is on the bottom. What can we do? 2 plus h. Everyone's satisfied that this is 2 plus h.
Yes.
Who's not satisfied? Okay. All right. So what are we going to do with this? I'm going to explain what's really going on with this next question here. This next question is simply to find the derivative. And how do we do that?
Rise over
Yep. We have, when they say find the derivative, what this also means is this here. The derivative at its first principle is really simply the rise and run, as Manny just said, but we have to do something to it. Is it LIM? What does LIM stand for? Means limit. We can go to extreme limits. We can go to as high as we can, or we can go as low as we can. For gradients, it's as small as we can, not in the negatives, but as h approaches 0. Think about it. If h eventually becomes 0, what does 2 plus h eventually become? H is shrinking to 0.
Just 2?
2. It's just 2. Now, what does that mean? This is a visual explanation. So right now, we worked out from P to Q. We used P to Q as a rise and run all the way down here, became 2 plus h. We whacked them in. What we're saying now, we don't know what this point is, but it's a little bit further down the track. But the gradient is equal to 2 plus h. But what we're going to do now, we're going to shrink the space between. So here's 1, and here's h. We're going to gradually shrink that back. So, for example, we might choose another point here. I might shrink it back. This point here is a little bit smaller. The h is a little bit smaller than the original h. We're taking a step back. So visually it looks like this. We're going here. H is shrinking, H is shrinking, H is shrinking, H is shrinking, H is shrinking. And what's this? H is 0. H is 0 now. And at H0, what's the gradient?
2.
It's 2. And looking at my ruler, what did we create? Today's lolly. What did I just create here? A tangent. We created a tangent at exactly this point here. I'll get to lolly soon, Maya. Okay. From these 2 points, we shrunk h all the way down to 0. And as we did that at P, created a tangent. We created an instantaneous answer, rate of change right here. With limits. That's what we did. Okay, this is derivatives from first principles. All right. Any questions with this one? Can you go to, yes, if we start over here. I know what you're asking. I'm just can we go negative? Oh yeah, you can go negatives, yes. But H will still shrink to 0. H doesn't go negative, but the eventual answer can become negative, like a negative gradient. Good. Okay. Let's see if you can work this one out by yourself. Okay. This is the next example. Slight difference though. And we said that y equals x squared plus, we did plus 3. And we did the gradient became 2. Just keep that in mind. This will be our next lovely question. Over here, very similar. Got a piece of paper, grab it out, have a bit of practice. I've changed the equation. X squared plus 1. Okay. So let's do this. Rise and run. Can you please begin this process here for the information given? I'm going to give you a head start. Then I'm going to ask around to see what you've got. Grab a piece of paper, please, if you haven't.
That's why I do the 2.8 again.
Yeah.
It's good looking and it's good sense. It's the same thing.
Okay. This time, let's do it. Okay, so this one here is slightly different. Okay, slightly different, but it kind of becomes the same thing. Okay. Start with that, please. Start with that. I know we've kind of already done this. It's the same thing, but I just want you to, I guess, start it from scratch. Okay. Yeah. Okay. So as Zach said, let's start from scratch. This is what we're eventually going to sub in though, which becomes the same equation later. Okay. This time round, ignoring this, just say you didn't see it. We have x and fx, but we have another point a bit further down the track. Okay. So this is x, but what am I missing in here? Plus h. Starting point plus a little bit more. Are we okay? Yes. We do the same thing. Okay, what's my y2?
Y2 is function of h.
Function of x plus h. Take away my y1, Tim. fx. What's my x too many?
X plus h.
X plus h. And z?
Minus x.
Minus x. Good. Now let's sub this into our equation. So, Perry, fx plus h. What does this change into? Thank you. Plus 1. So I was looking at this. I'm going to take away this, just not to distract us. I'll rewrite it. X plus h squared plus 1. What does this become, Jesse?
X squared plus 1.
X squared plus 1. Okay. Have I done a mistake?
So minus or 1.
Thank you. Make sure if you've still got two things you're going to subtract, do it in a bracket. Underneath, Nathan, my denominator, h. X plus h squared using our, it's going to become, remember, this is x plus h times x plus h. Okay.
X squared plus 2x h plus h squared.
It's h squared, thank you. Still have the plus 1. Okay. Minus x squared minus 1. Okay. Make sure that that's there. On the bottom of page. Emily, I want to simplify my numerator. What can I get rid of?
The x squared and 1.
X squareds and the 1. We are left with 2hx plus h squared plus h. Finally, Maya, everyone's being asked the same question. I just noticed on the last one. Maya, what do I do with the h's? 2x plus h, thank you. So, in the last one, we subbed in x equals 1, and we're going to do it again here at x equals 1 right here. If I substitute x equals 1, I get a 2 plus h once again. Now, I'm saying that not every single, I'm not saying that this whole topic, the answers are going to be 2 plus h for every single one. But what we do now, found our gradient, we want to shrink, where's my rule? What are we going to try and do from here to here? Gabe, what are we trying to do here?
Oh, between points.
P and Q. What's the focus of the question that I already rubbed off?
Find the grade.
Find at where? Which point?
Between P.
Between P and Q. Now, not quite. I know you don't have the notes right now. I wiped it off. Does anyone remember where was the specific point we needed? At P. Okay, we want it back at P. But what's the value of the x at P that I was trying to get you to ignore? 1. It's 1. So we're trying to get back to 1. Okay? Trying to get back to 1. Okay. Now, I made a mistake here. What should be here? This third lolly. There's a mistake here.
The 1?
No.
On the X?
The x is still there, actually.
Right.
Yeah. H has got cancelled out. The x is still there.
We've already got it written.
Yeah, I know. But I did it. I rewrote it again and became a mistake. Our answer for here is 2x plus h.
You subbed in 1, right? Yeah, you subbed in X.
Yeah, I wanted to take a step back here. Anyway, so it becomes 2 plus h. But what must we do to this gradient as we did in the last question?
Shrink it.
Shrink it.
Limit.
Yeah, what's the mathematical term? Limit, Jesse. Where's this limit going?
0.
Oh, to 0. Okay. What's our final answer? 2. Both answers are 2. Can anyone see a pattern? Okay. First equation is x squared plus 3. Second equation is x squared plus 1. The derivative for the first one was what do we have? 2, and we've got it 2 again. Derivative of 2. Can anyone see a shortcut or a pattern?
The power.
It's the power. Okay. This power here. Next class, I'm going to. This is the shortcut for next class, and I'm going to stop right here.
What if the dilations different?
Sorry?
What if the dilations different?
Good question. Yeah, good question. We'll do that next class. Okay. This is the shortcut. If you have x squared, the gradient becomes 2x. You drop down the power down in front of the x. The new power is what? Power of? Simply 1. Okay? But for this one, what did we substitute in? What point were we interested in? We were interested in that point at x equals 1, which became 2. Okay? Are we okay?
Yeah.
Okay. All right. This is the last lolly question. I want to see if people okay. This is worth 2 lollies. Okay. All right, notice here. Let's look carefully. Lolly, 2 lollies. If anyone can get what's happening here. We have a quadratic, power of 2. But we derived it, and this new graph did this. Okay? So what I'm trying to say here, let's just focus on the x squared as its own graph. X squared, it's a quadratic. The tangent here, when we derived it, became a line, but actually became 2x. Okay, so if I derive x squared, remember when we did our equation without subbing the point in? 2x. 2x is what type of equation is that? It's a line. Okay? When we derive quadratics, they become lines. Now let's look at this here. Let's focus on 1. This is y equals 1. This is a constant line. Question for 2 lollies today. What's the derivative of this line? What's the gradient of this line?
0.
It's 0. It's flat. And so this quadratic became a line, and this constant, what did this constant become? It disappeared. It's 0. That's why when you derive constants, or you apply a gradient to a constant, is there any gradient? There is, but it's equal to 0. It's really like that. Okay. I hope I didn't, for that last bit, muck you up.